Hello everyone, I'm Golden Ashwini. I'm here to present pipelining in computer architecture and organization. So pipelining in this the basic concept is planning is an implementation technique whereby multiple instructions are overlapped in execution. Takes advantages of parallelism. So key implementation techniques used to make fast CPUs. A pipeline is like an assembly line. So, in a computer pipeline, each step in the pipeline completes a part of an instruction, like the assembly line. So, different steps are completing different parts of different instructions in parallel. So, each of these steps is called a piped stage or piped segment. So, the stages are connected one to the next to form a pipe instruction, enter at one end. So, progress through the stages and exit at the other end. So, the throughput of an instruction pipeline is determined by how often an instruction exits the pipeline. So, the time required between moving an instruction one step down the pipeline is processor cycle. So, if the starting point is a processor that takes one clock cycle per instruction, then pipelining decreases the clock cycle time. So, pipeline for an integer subset of RISC architecture that consists of load, store, word, branch, and integer ALU operations. So, every instructions in this RISC subset can be implemented in at most 5 clock cycles. So the 5 clock cycles are first one is instruction fetch cycle. In this send the program counter PC to memory and fetch the current instruction from memory. So PC equal to PC plus 4. Okay, next one is instruction decode or register fetch cycle. So decode the instruction and read the register. Do the equality test on the registers as they are read for a possible branch. So compute the possible branch target address by adding the sign extended offset to the incremented PC. Then decoding is done in parallel with reading registers. So which is possible because the register specify or at fixed locations in RISC architecture known as fixed field decoding. Then third one is execution or effective address cycle EX. So the ALU operates on the operands prepared in the prior cycle, performing one of the three functions depending on the instruction type. So memory reference, the ALU adds the base register and the offset to form the effective address. So register to register ALU instructions. The ALU perform the operation specified by the ALU opcode and the values read from the register file. Then register to immediate ALU instruction. In here the ALU perform the operation specified by the ALU opcode and the first value read from the register file and the sign extended immediate. Then memory access. In memory access MEM, if the instruction is loaded, memory does a read using the effective address computed in the previous cycle. If it is stored, then the memory writes the data from the second register, read from the register file using the effective address. Then the last one is write back cycle. Register to register ALU instructions or load instruction. So write the result into the register file whether it comes from the memory system for a load or from the ALU for an ALU instructions. So in this actually pipelining have a 5 stages for RISC processor. So each of the clock cycles from the previous section becomes a pipe stage, a cycle in the pipeline. So each instruction takes 5 clock cycles to complete during each clock cycle. So the hardware will initiate a new instruction and will be executed some part of the 5 different instructions. In here we have three observations. Use the separate instructions and the data memories which implement with separate instructions and data caches. Then the second one is the register file is used in two stages, one for reading in ID and one for writing in WB. Need to perform two read and one writes every clock cycles. Then the third one is does not deal with PC. To start a new instruction every clock, we must increment and store the PC every clock. So, and this must be done during the IF stage in preparation for the next instruction. So, to ensure that instructions in different stages of the pipeline do not interfere with one another. This separation is done by introducing pipelining registers between successive stages of the pipeline, so that at the end of a clock cycle all the result from the given stage are stored into the register that is used as input to the next stage on the next clock cycle. Thank you. Thanks for listening.